A warm welcome to all the viewers. Today's session of Tourism and Hospitality Research, we will be talking about EFA, that is Exploratory Factor Analysis. In the previous video, I have explained to you how to conduct confirmatory factor analysis in AMOS to check your measurement model. But before that, in case you are unsure, you do not have proper theoretical background to support the indicators, the questions, or the observed variables which you have included in your survey questionnaire, then in that case, if you are unsure that whether those observed variables contribute to the meaning of your latent variable which you want to measure or not, in that case, we conduct exploratory factor analysis, and that is done in SPSS. So now let us go ahead and understand the concept of exploratory factor analysis and then see how to do it actually in SPSS. EFA is a statistical method used to identify the underlying structure of a set of variables. Sample size for doing EFA should be at least 5 times the number of observed variables, which have to be measured on an interval or ratio scale. That means they have to be continuous in nature. The goal is to determine the relationships between observed variables and the latent variables. It is used when researchers are uncertain about the underlying factor structure, and it helps to discover the factor structure of a measure and assess its internal reliability. These are some of the relevant terms which we need to know before we delve into how to conduct EFA in SPSS. The first is KMO. KMO measure of sampling adequacy. A higher statistic value, that is closer to 1, starting from 0.50, suggests that the factor analysis is appropriate for the aggregated data, whereas in case you have a low statistic value that is below 0.5, it suggests that it is improper to do a factor analysis in that case, and it indicates an insufficient sample size. Ideally, the KMO value should be above 0.7. Second is Bartlett's test of sphericity. It compares the correlation matrix to the identity matrix, used to investigate the hypothesis that there is no correlation between the variables in study population. Now, in case you don't have any correlation between your variables, the latent variables, then it becomes meaningless to conduct factor analysis or exploratory factor analysis, and even it becomes meaningless to go ahead with that kind of a study, because all kinds of relationships between the factors, between the latent variables, depend on their correlation. Everything is correlated up to a certain extent to another thing. That is why a significant result, that is p-value less than 0.05, means that the variables are sufficiently related to each other, which is essential for conducting a meaningful EFA. But the matrix is not an identity matrix. Perfect correlation amidst itself, that is R is equal to 1. Correlation coefficient R is equal to 1 in case it's a perfect correlation, but no correlation with other variables, R is equal to 0. That indicates or depicts a identity matrix. So it should not be an identity matrix. Problem with Bartlett's test is that if there is large sample size, then small correlations become statistically significant automatically, and then you conduct EFA, you will get that the latent variables has some indicators which are contribute to the meaning of latent variable, but that might not be so meaningful for you and affect your results eventually. Communality, that's the third term. It is the degree up to which a variable shares the variance with every other variable under consideration. Variables with small values, that is lesser than 0.50, may be considered for deletion. We will see how it is all done in EFA. For now, let us just concentrate on understanding the meaning of these terms and be acquainted with their names. Next is percentage of variance, that is contributed by each factor as compared to the total variance exhibited by all factors. Eigenvalue, it signifies the cumulative variance as explained by individual factors. Factors possessing value above 1 are chosen for further examination. Scree plot can also be used for this purpose. We will see how eigenvalue tells us that how many factors can be formed out of our data. Scree plot, eigenvalues and factor number plotted as per the sequence of extraction. It uncovers the most desirable count of factors for retaining in final solution. Factor loadings or factor variable correlation. These are simple correlations which exist between variables and factors, and they reveal how well the observed variables represent the latent variable. Factor matrix includes factor loadings of all variables on every extracted factor. Model fit, finally we are going to check the model fit. A good model fit has lower than 50% of the non-redundant residuals possessing absolute values higher than 0.5. Rotation methods are quite important. Rotations that allow for correlation are known as oblique rotations. Rotations that assume no correlation amongst the factors are orthogonal rotations. So you have to make a choice over here, whether you are going to do the direct oblimin rotation or you are going to select the varimax rotation. In direct oblimin, factors are allowed to be correlated. In varimax, most widely this option is used as it reduces the count of variables which display extreme loadings, it could be low or high, on a factor, and also decreases the factor's correlation. It makes it possible to identify a variable within a factor. Varimax gives orthogonal factors, whereas oblimin restricts the factors from being orthogonal. So we are going to use varimax rotation method when we do our EFA. This is the EFA process. The first is formulating the problem. What all latent variables with their observed variables you need to see whether your observed indicators are following a pattern. They can be attributed to some factor. They can be attributed to some factor to provide a meaningful solution to that factor. So that is formulating the problem. Next is checking the conditions for EFA. As I told you, we have to check the KMO and Bartlett's test of sphericity. Use an accurate factoring method. Choose how many factors to include. So that is what we will see. Rotation of factors will be doing by varimax rotation. Model fit assessment, which we saw just now, running the EFA, and then the results interpretation. So it is going to be quite simple. If you stay tuned, keep watching this video, I'll show you how to do it actually in the SPSS. So we'll come to this result interpretation later. For now, let us go to SPSS and check it out how to do EFA in SPSS. Now, before I go into showing you how to do EFA in SPSS, let me show you the questionnaire file. So this is our questionnaire file where we have certain indicators for each of the latent variable. As you can see here, food quality is made up of 4 reflective indicators, FQ1 to FQ4, cultural authenticity CA1 to CA4, service quality SQ1 to SQ4, value for money VM1 to VM4, behavioral intention BI1 to BI4. So in case I want to explore that whether they all come together, say in case of value for money, VM1 to VM4 come together as observed indicators to provide meaning to the value for money latent variable, then I need to conduct EFA because I might not have a strong theoretical background to support this. In case I do have a theoretical background, a strong backing, Then I need to do the confirmatory factor analysis. In that case, I do not have to conduct EFA. It is not mandatory. So now you have understood. Now I want to see whether they form this structure or not. So I'll go into the SPSS file. All of the indicators are measured on Likert 5-point scale from 1 to 5, where 1 means strongly disagree, 3 means neutral, and 5 means strongly agree. So you see here, all of them are shown over here. FQ1 to FQ4, CA1 to CA4, SQ1 to SQ4, VM1 to VM4, BI1 to BI4. So what we need to do now, we'll go in analyze, we'll go in dimension reduction and factor. Under factor, I need to include all of these observed indicators. I'll click on FQ1, press the shift button, and then click on BI4 and transfer them into the variables tab. Then I go to descriptives. Under descriptives, I have to check initial solution and KMO and Bartlett's test of sphericity. So these two options need to be checked. I click on continue. Then I go to extraction. Under extraction, I should be checking on principal components method. And then if I want to see the scree plot, I can go to scree plot as well. Now, based on eigenvalues greater than 1, I will be forming my factor. So that is why eigenvalues is kept greater than 1. Maximum iterations for convergence is 25. That is okay. Click continue. Go to rotation. Now here I'll check Varimex method of rotation, and maximum iteration for convergence remains 25. Continue. Scores, I do not need to change anything. In case I want to save the variable scores, I can click over here. For now, I don't want to save any scores. Continue. In options, exclude cases list-wise and suppress small coefficients, that is absolute below value below 0.5. So I want to suppress the small coefficients who have the absolute value below 0.5. Continue and press OK. Now we are in our results, and you can see here KMO measure of sampling adequacy is 0.851, which is quite good. So it is well above 0.5, which is the threshold, and the more nearer it is to 1, the better it is. In this case, it is quite good, 0.851. Bartlett's test of sphericity, the significance value is 0.000. That means Bartlett's test of sphericity is significant. It means it is less than 0.05, and there is a correlation between all my factors. So in case there is a correlation, then I can go ahead with the factor analysis, EFA. In case there was no correlation amongst my variables, then there's no meaning to do EFA. And in case there's a perfect correlation, that is the correlation coefficient is 1, then also it does not mean any meaning to conduct EFA. Now we'll go to the communalities, and you see here all of them are above 0.5. So we need to check if anyone is below 0.5. We'll keep a note of it, not just go directly to the SPSS file and remove it. For now, we'll just look at it and record it. In this case, none of them is below 0.5. So all of the commonalities of all are 20 indicators, 4, 8, 12, 16 and 20 is quite fine. That is above 0.5. Now we come to total variance explained. Here we will come to know that how many factors can be formed out of our observed variables. Now you see the eigenvalue which is above 1, the eigenvalue above 1. So you see in this case there are 5 eigenvalues which are above 1. 1.29, 1.53, 2.03, 2.07, 7.32. So this means we can have a structure of 5 factors being formed out of our delta, and the cumulative percentage is 71.323. That is quite good. So that means 5 factors, if taken cumulatively, explain 71.323% of the variance in the model. So that is quite good in this case, and we have a structure which can be formed out of 5 factors as we require, because we have 5 latent variables according to our hypothesized structure, right? Even if we see the scree plot, you see here that when it takes a bend over here, how many factors are above this? This is 5, right? It takes a bend at 5. So it takes a steep bend at 5, and then you have above 1. So 0 and 2. You see here it's 1, right? So above 1 we have 1, 2, 3, 4 and 5. So 5 factors are there. 1, 2, 3, 4, 5. How did I come to know? Let me tell you once again. 1 might be lying over here, as you see, between 0 and 2. So above 1 you have 1, 2, 3, 4, 5, right? So this is the way we check it out. So this is the scree plot, which tells us the same thing which we saw in this total variance explained table through the eigenvalues. Now we'll go to the component matrix and see. This is the loadings. These are the loadings of different indicators. So for now, we'll come to the rotated component matrix, which we checked in EFA. We opted for Varimax rotation, principal component analysis, and now we check. So FQ1 to FQ4, they are well forming one factor, which is this factor. CA1 to CA4, they are well forming one factor together. SQ1 to SQ4 forming one factor together. VM1 to VM4 forming one factor together, and BI1 to BI4 forming one factor together. So our structure is quite okay. In this case, you see that some of the indicator is missing, its loading is missing, or it's falling into some other construct, then we need to give a look at our data, and then we might plan to delete that indicator out of our data because that is not contributing to the meaning of the latent variable which it should prescribe to. So in that case, we might delete it, but consider deletion only one by one, not together, because deleting even one indicator out of your structure might affect the values of other indicators as well. So that was all about EFA. Quickly, I told you and explained you how to do EFA in SPSS. I hope it was quite convenient and meaningful for you. Now let us check it out, how to interpret the results. So now we are here. An exploratory factor analysis was conducted through the application of PCA coupled with Varimax rotation. The threshold for minimum factor loadings was established at 0.50. Additionally, the communality of the scale, which serves as an indicator of the extent of variance within each dimension, was evaluated to confirm the levels of explanation were acceptable. The findings indicated that all communalities exceeded the threshold of 0.50. A key element of this method involves analyzing the overall relevance of the correlation matrix through Bartlett test of sphericity, which delivers a statistical assessment of the chance that the correlation matrix possesses notable intercorrelations among some of its variables. So what I am showing you over here is that how do you interpret the results of EFA. So in our case, the outcome was statistically significant. Chi-square n is equal to 204. That is our sample size. We had a sample size of 204. The chi-square value was 2428.472. The significance value, the p-value is lesser than 0.05, lesser than 0.001 in that case, because it was lesser than 0.000. We write it as 0.001, lesser than 0.001, thus affirming its appropriateness for conducting factor analysis. The KMO measure of sampling adequacy, which evaluates the suitability of the data for factor analysis, was also recorded at 0.851, which was quite good. In this context, data exhibiting MSA values higher than 0.800, MSA's measure of sampling adequacy, are deemed suitable for factor analysis. Ultimately, the factor solution derived from this analysis identified 5 factors which collectively account for 71.323% of the variance present in the data set. These are some of the useful references which you can refer to for learning more about EFA. I hope it was quite knowledgeable and interesting for you, and you will definitely share it with your friends and faculty colleagues. Thanks for watching. Keep learning and keep watching for more.